Chlorine exhibits a very strong, pungent odor that is similar to bleach but is much stronger. It's easy to detect by sense of smell at very low concentrations. By itself, chlorine is non-explosive and non-flammable, but it is a strong oxidizing agent that will support combustion with flammable gases and vapors. If chlorine comes in contact with organic combustible substances, such as oils or greases, explosions and fires may result. The most common way for chlorine to come in contact with incompatible substances is through spills and releases. Hazardous conditions can also result if chlorine comes in contact with any of these substances. Chlorine reacts readily with many organic chemicals, often violently. Chlorine reacts with water to form hydrochloric or hypochlorous acid. It's also incompatible with moisture, water, and steam, forming corrosive acids when mixed. At 483 degrees Fahrenheit, chlorine will oxidize steel, essentially burning it. Chlorine reacts with steel at lower temperatures under certain conditions. Oxidation could lead to a fire, which should be avoided since water cannot be used on a chlorine fire. Chlorine exists as a gas or a liquid. This chart compares the properties of chlorine gas and liquid. Again, it's important to remember that gaseous chlorine is heavier than air, so it will settle into low areas, such as basements, creek beds, and ravines. Liquid chlorine becomes a gas at -29 degrees Fahrenheit at atmospheric pressure. Liquid chlorine has a clear amber color, while chlorine gas will exhibit a faint yellowish color at low concentrations and greenish yellow to green at high concentrations. Depending on the humidity, chlorine gas is usually not visible at concentrations below about 25 parts per million.
This video will feature large-scale, controlled releases of chlorine to demonstrate its properties. These releases were part of the Jackrabbit Program, which was an outgrowth of an analysis conducted by the Department of Homeland Security's Chemical Security Analysis Center, or CSAC, that began in 2008, of large-scale toxic chemical transportation within the U.S. After researching the adverse health effects and total amount transported annually of many chemicals in commerce, CSAC chose chlorine and ammonia as initial chemicals to conduct real-world release trials to study the dispersion properties of each chemical. In the Jackrabbit Program, there were a series of chlorine releases ranging in size from 1 ton to 20 tons in the remote salt flats of Dugway Proving Ground, an Army installation. The tests were conducted and managed by CSAC in 2010, 2015, and 2016. The Chlorine Institute was involved in the last 2 years of the test to assist with the chemical transfers in the remote test location and by providing donated chemicals for the test. The industry volunteers were professionals who regularly use and/or produce chlorine and are experienced in the safe transfer of chlorine from one vessel to another. There were select CI members who were paid for their chlorine handling services. These CI members worked for emergency response and environmental remediation companies, not chlorine-using or chlorine-producing fixed facilities. The video is time-lapsed and will show the initial release, followed by the first 5 minutes, then 15 minutes, and finally 30 minutes after the initial release. Chlorine is heavier than air. And after the initial release has subsided, chlorine will settle and move close to the ground. At the 30-minute mark, you can no longer see any chlorine vapor under the tank from which it was released, although the concentration is probably still 10 parts per million, which is the IDLH level for chlorine. Now, for comparison, we'll view a side-by-side of a heavier-than-air material, chlorine, and a lighter-than-air material, anhydrous ammonia. Very quickly, the chlorine sinks to the ground, while the ammonia fills the airspace as the volume of ammonia increases, even blocking the view of the tank. Even though both of these materials are considered toxic inhalation hazards, you can tell by this video that there are different strategies to respond to an emergency involving chlorine versus a lighter-than-air material. The way ammonia rises is a significant consideration for any elevated surface and any personnel protection plan. In contrast, chlorine runs along the ground or seeks lower elevations. The chlorine reaches the end of the ditched area and basically stagnates. The ammonia has engulfed the entire viewing area of the camera, and the tank is no longer visible.